But so now we're actually going to show you, we're going to talk about some of the concepts that we talked about in the video. We're not really going to be able to talk about weight. Everyone pretty much knows what weight is, perhaps especially after the holidays. We're especially conscious of it. And we're not really going to be able to talk about thrust because we didn't really bring an engine with us. But we are going to be able to talk about the other two forces, lift and drag. So we need to get our miniature wind tunnel set up. Oh, so while we're doing this, it's probably a good idea if you want a really good view to come up front. So maybe you can sit in some of these seats up front, or just sit on the floor up here, because you really need to be closer to see what's going on. Does anyone know what this is? Yeah, good. So it's always good to bring an extension cord. Alright, so essentially what this is this is a miniature wind tunnel. So in aerospace engineering, we're both aerospace engineers, we use wind tunnels a lot to test airplanes. It would be really cost inefficient if you built a giant airplane and then flew it and it crashed and you were like, oh, that design was really bad, we should change things. So instead we test models in wind tunnels. We don't do it so much anymore because we have computer programs which will actually test out the aerodynamics. This is sort of the field of research. They'll test out the aerodynamics of an airplane on a computer, so we don't have to do a lot of wind tunnel testing, but they're great for student projects and demonstrations like this. So this is a mini version that our friends made. So what we're going to do is we're going to put a couple of different things in the wind tunnel. We're going to turn on this fan here at the right side. It's going to suck the air through. And these straws are just to straighten the flow, so it's not all what we call turbulent, which is when it's swirling and everything. They actually have these on real wind tunnels. They're just a lot bigger than this. So the flow is going to come in here, flow over our square or our wing, whatever we have in there, and then go out the back. And we're going to use this dry ice. We're just going to put hot water on it, and it's going to start to evaporate and create a lot of smoke. And so we're going to put this in here, which will allow us to see the flow over the square or the wing, really help us to see what's going on. So we're going to turn this on, and so you can hear it start to go. So I will turn the object and sort of talk about it. And Justin, do you want to do the... So as you can see, it's going to start to smoke a lot, and then we'll put the lid on. So the first thing we're going to talk about is drag. And so you can see, so the air is flowing through this way, and if I have the square like this, you can see there's a big area that's perpendicular to the flow. So the air is going to come in, and it's going to smack on the side of this square, and it's not really going to have anything anywhere to go. Yeah, you can just put it down. So there, you can see the flow coming in, and it's coming in and it's smacking into the side of this square, and it has to go all the way around the corner. So this has a really high drag. It's kind of like when you put your hand out the window straight up, because there's a really big area that the wind is smacking to. If we turn it sideways, so the air hits this point and it goes over to one of the two sides. So that's a lot smoother flow over the square. So this has a little bit less drag. It's still a lot of drag because it's a really big and blocky object. This is why you never really, yeah, you may need to put some more water in there. You really never have wings that look like squares because they don't help your airplane fly very well. They're pretty bad. So a square is not a shape that we see in aircraft wings. So I'm going to put in a different shape really quickly. And we're going to put in a circle, which is another shape that airplane wings don't have, but it's a lot sort of less drag.
His orange is bit.
So it's sort of spitting out chunks of dry ice, but you can see the flow. Well, that's it. So you can see the flow. It's coming over and it's going around the sides. You can move it up and down once you do that. Like just move it until it goes over the top. I don't know. More dry ice. Maybe not always. Just Yeah. Well, let's try that, and let's put the wing in because the wing's the coolest part. I mean, we obviously don't have airplane wings that are squares or circles because they don't fly very well. They don't produce any of that lift force that we talk about. So we're going to put in this airfoil, and this airfoil comes in its own special box because it's a very nice airfoil. I was told not to mess this one up, so. I don't know. That's cold. So this airfoil, so we're going to talk about sort of how airfoils produce lift. So you can see this is an airfoil. An airfoil is essentially just a cross section of wing. If you went out to an airplane and chopped part of the wing off, they would chase you out of the airport and probably be really mad. But if you theoretically did that or think about that, what you have is this section here, which is an airfoil. So we have this is sort of a really exaggerated airfoil. And you can see how it's really curved on top and really flat on bottom. Real airplanes don't look like this because this doesn't fly very well either. This is sort of the shape that you see. This is like the exaggerated version. So one of the things that happen that creates lift is the air flows faster on top than the bottom. So you have the air going over the top and it accelerates and it goes slower on bottom. And so that causes a lower pressure on top. So there's high pressure on the bottom of the wing and low pressure on top. And pressure wants to go from high to low, so there's sort of a net pressure difference, and it pushes the airplane up. That's sort of one of the mechanisms. It's not the only mechanism, but that's one of the ways that lift works. So we're going to put, actually let's start with this big airfoil. So we're going to put this big airfoil in, and what you should be able to see is you'll see, we'll just turn it like this, sort of straight into the flow. This is zero angle of attack, as we said in the video. And you'll see the air going faster over the top than the bottom. I should say, you should see, if our dry ice behaves as it should.
Why does it go faster on top?
Just because of the curved design just makes the air accelerate.
It has a longer distance to travel. So the air is coming in at the same speed. It has a longer distance to travel over the top. So it's going faster.
Yeah. So all right, well that appears to be working, so. All right, so, yeah, so you can sort of hold it up so you can see it going over the top. So you can see it going over the top, and it's going fast, and then we move it to the bottom. It's really petering out there.
Yeah.
We are not sure of the correct dry ice to hot water ratio. Is it clogged?
It might be
Just somebody freeze your lip. It's science. You're in a lab coat. You have to take risks.
That's kind of petering.
Yeah. Well, as you can't see. Maybe, yeah. See, this is what science is. You can just, when you mess up, you just be like, oh, well, it's just science. We're just trying things until it works.
That's all right.
Which is sort of what doing a PhD is also like. Not that we're bitter or anything. All right, there we go. I think our water wasn't hot enough. I think, yeah. So you can see the flow is really coming here, and it's really accelerating over the top. And if you can't see, you're welcome to come up a little bit. I know our smoke screen isn't terribly fast. But yeah, if you move it up and down, you can sort of see the difference between the bottom. Put some more water in. It's science. That's
clogging.
This is
You didn't
why
know you're in the splash zone.
Yeah. This is why we use real wind tunnels and not.
Oh, there are pieces of foam.
Here, let's start out. Do you want to get just a little piece? Sure. So does anyone have any questions while we're trying to make this work? Any questions about airplanes or anything? Yeah.
No, it's the question. Does this usually happen with the dry ice?
This is only my second time using this wind tunnel, so I'm going to say yes so I don't feel bad. This usually happens, and it's not just that we're bad at it.
I think that's good.
Yeah.
President.
Sure. video was funny, right? So
Yeah.
it wasn't a complete loss.
All right.
I think we can do it. All right, so there you go. All right.
There you go.
And so what we're going to do is now we're going to start to turn it up. It's like a pity clap. So now we're going to start to turn it up, and this is increasing the angle of the attack, like we said in the video. And it's increasing the drag, because there's a larger area that's in the flow. And does anyone remember what we called it in the video when you get too high of an angle of attack and you start to use lift? Stall, yeah. So what you can see is here, like if we turn it up really high, you would never, if your airplane is ever like this, that's bad. But you can sort of see the flow here is really swirling around, and this is what we call turbulent flow. This is bad. You really want like this here. The flow is really, it's attached to the wing. It's what we call laminar. It's really attached to the wing, and there's little turbulence. And this is really good because it gives us lift. But when we turn it up really high and we get a lot of turbulence, we lose lift and we also create more drag. So this is bad. So you can actually, like, if you're flying in a really small, has anyone ever been in like a small, like 2 to 4 person airplane, like a really small Cessna or something? Okay, yeah, a few people. So my friend has one. He took me out and he was like, do you want to see what stall feels like? He's like, no, I don't really feel like dying today. Maybe we should just like, land. But so he did this, and so you sort of pitch up and up and up, and then eventually the aircraft, obviously we were fine. I'm not a ghost or anything. But the aircraft just sort of starts to, go down a little bit. You can actually feel that stall and that loss of lift. So it's pretty cool when you realize that your airplane's not going to fall into the sky. So we're going to try this Little Wing. Which is also a good song by Jimi Hendrix, but that's unrelated. I should say too, another nice thing about airplanes, so people are always worried like, you're like in an airplane up above, and like if the engines quit, everybody's always worried like the airplane's just gonna fall out of the sky like a rock, which actually isn't true. Airlines can glide a lot, so they can glide pretty far because the thrust, remember, is said what comes from the engine, and going fast helps to produce lift. But you're still going fast even if the engines go out. So you still have a little bit of lift, and you can actually glide to the airport. And there have been a couple airplanes that just ran out of fuel. There was one in Canada, they thought it was gallons and it was liters, and they ran out of fuel, but they landed successfully. I'm not blaming Canadians, if anyone is Canadian. But. So here with this really thin airflow, can you move it back a little bit? Yeah. You can really see the flow, and if we turn, see, if you come up really close, you can see. Yeah, so if you want to take a look, you can see there's really some vortices happening here at the back of the wing, and that's turbulence, and that's bad, because that's going to cause us to lose lift, and also it's going to create more drag, and that's sort of when our airplane starts, falling out of the sky eventually. So that's not really good. Yeah, so commercial airlines are really cool because they have these things on the back called flaps, which are these, like if you're ever landing and you hear this mechanical noise, it's not the airplane coming apart, it's these things at the back of the wing extending. They sort of come off the back of the wing like this, and they actually make the wing longer and more curved, which lets you have more lift at slower speed. So that's what we use for takeoff and landing, because when we fly at cruise, we're flying at like, 450, 500 miles an hour?
Yeah.
But you obviously can't take off that fast. You can't drive that fast on the ground. Takeoff speed is about 120 miles an hour. So we have these flaps and we extend the airfoil, we get more lift at slower speed. So that's how we take off and land. Let's just try it once more. Let's just put a little more water and dry ice. We'll just do the, if anyone wants to come up closer and sort of see the laminar flow and the turbulent flow, now will be your chance. We'll do it once more. I think we need some more. Dump the water out in that bucket, in this bowl, and then we'll put the water in there.
Do you need more hot water?
Yeah, we still got a lot in here.
I think that was, I don't know, that didn't work too well.
What?
That hot water.
I think it's just because we had a lot of dry ice.
Okay. Science, everybody. Just try it till it works. And eventually they give you a PhD. You can get a job. That's the story of the last 4 years for us. It's Friday night, you got it. So are there any more questions about airplanes or anything in general? No, everybody wants to go have dinner and get out. Or we just answered all your questions. That's what it is. We
Yeah.
just learned so much. There are no further questions.
So what's happened in aviation since, the first set of airlines gone up from to today? What are the innovations? Other than making them lighter and bigger?
Yeah, that's essentially it. Aviation has been, here, I'll do this demo while we have the dry ice, and then I'll answer that question. So as you can see, we have the laminar flow, and we turn it up, and there'll be a point, sort of there we're getting it. This is a pretty high angle of attack. Sort of there you can really see the vortices, and it's also hitting the wing here, deflecting, so this is not good. But, yeah, and you're welcome to come up and take a closer look if you want to. But yeah, so what's happened in aviation in the past, since the Wright brothers flew about 100 years ago, it's really about efficiency. That's the main thing. Sort of we know how to fly, and airplanes don't fly differently today than they did in like the 30s. Really the difference is in efficiency. So we're working at making engines more efficient. Boeing's new airplane, the Dreamliner, it's made out of all composite material. So it's very little metal, so that's lighter, and so you can carry more passengers on less fuel and make the airlines more money. Make the airlines more money. Which I thought the $25 bag fees did that, but apparently that's not enough. But yeah, really efficiencies in the wings, efficiencies in the engines. Like if you can get a 1% increase in efficiency in your engine, yeah, that's incredible. So it's just really minor increments, just sort of making bigger airplanes that fly with less fuel. Another big increase, which is sort of the area that we study, is in the automation that's used. So back when you had World War II and those type of airplanes, the pilot was doing everything. They used to have 4 people in the cockpit of like a Boeing 747 or something that would fly you from here to maybe Europe or Asia. There was a guy called the navigator who would like have a map and would say, go straight until you hit Portugal and then turn left. Or you would have someone called the engineer who would actually look at these gauges that says, oh, your engine is functioning properly, or your engine is broken, you should probably land. That's generally a bad thing, especially when you're over the ocean. But now they have automation. Now the computers can take a look at that. So on these on domestic flights, we only have 2 people in the cockpit, and for these long oceanic flights, we generally have 3 people still, just so someone can take over. But yeah, actually, airplanes can pretty much take off. They take off, the pilot goes down the runway, pulls the yoke back, the airplane goes up into the sky. They can push a button that says autopilot on, and the airplane can land without the pilot really doing anything. I was flying from Austin to Charlotte, and we landed, and we went into these clouds, and I was like, oh, we're in clouds, we'll break out of the bottom, and I'll see Charlotte below, and then we'll land. And I was looking out the window, and I saw this light that was literally horizontal with the window. And that was all I saw. It was all fog, and there was a light. And I was like, I really hope it's not like a building or something. And then I saw some more lights, and we were on the runway. There was very little visibility. We really couldn't see anything. If it was a legal landing, it was like at the bare minimums. But that was, when you're trying to land in fog or things like that, that's when you're really assisted by the autopilot. In the early days, pilots could really only fly when they could see, unless they were incredibly gutsy. But now we can fly in all sorts of weather conditions, thanks to the automation. So that's been a big sort of advance, not with like the aerodynamics, but more with sort of aviation as a whole. And that's sort of the research that we work on human automation interaction. What should the human do and what should the autopilot do? So, yeah, that's a great question. Any other questions?
When I travel from Korea to here, or here to Korea, there's like a slight difference, like 2 hours or something, and so much faster than the other. So is it thanks to the wind or something?
Yeah. I'm not sure the specifics, but I'm pretty sure it's thanks to the wind. There, like the jet stream is over the Atlantic, and it's just whether you have a tailwind or a headwind, it helps you to fly. Because if you're flying with the wind, it's just giving you an extra velocity boost. So
Exactly. Even going to the West Coast, you'll get about an hour difference in the travel times between going west or coming back east.
Yeah, it also matters for how much fuel the airlines have to burn. So if you're going into the wind, you can't go as fast, you can spend a lot more fuel. So
What's your story with the battery grid line?
With
The battery.
Yeah, so essentially the plane, the Boeing 787 Dreamliner, they had lithium-ion batteries and they caught fire. I'm not sure of the specifics. It was, I think, the contractor's fault, but yeah, I think it was a new type of battery, right? Wasn't it? They were using the Dreamliner.
It was newly designed. It was designed specifically for
Yeah,
the
yeah.
The type of battery was. I mean, that's common.
Yeah,
I
it's
think
like
it wasn't the battery itself that caught fire. I think it was like the circuitry associated with it. Yeah, I'm not sure of the specifics.
They fixed it. We were supposed to fly on a Dreamliner, and then they started catching on fire, so they changed the flight version.
Yeah.
Yeah, I think we probably will have time for at least one more question.
So how do planes turn?
Yeah, so how do planes turn? So that's actually a question that I like a lot. It's not like you think. So like if you're in a boat, like if you've been in a boat, boats have rudders. And essentially if you're going in a boat, you just sort of turn the rudder and the boat goes, this way. You turn the rudder the other way and the boat goes the other way. Planes actually, they have rudders, but they don't really use them to turn like boats do. They essentially just bank. So if you've ever been on a plane, you've probably experienced this. Where you're on a plane and it's going along and then it banks. And what this does is, if you're just flying straight and level here, why don't you be the airplane? I'm going to explain this. So Justin is an airplane. He could be a 787 that hasn't caught on fire. So when Justin's flying just straight and level, the lift force. This is sort of like you're looking like head on the airplane. We should hold him horizontally, but we won't do that. We won't make him do that. So sort of you can imagine that here's the nose of the plane that goes back like this. So if he's flying horizontally, or what we call steady level flight, the lift vector just goes straight up. But if he banks to the right, a little bit of that lift vector is going sort of towards the center of the circle. There's still a lot going up, but there's a little bit going towards the center. And so that's going to pull him, if you guys back up a little, that's essentially going to pull him in a circle like this. And if he bangs, this is fun. We should do this more often. If he bangs this way, he turns like this in a circle. So planes have a rudder, but that essentially just sort of keeps them flying efficiently. The real way they fly is they just bank and then they automatically start to turn.
Yeah.
So the next time you're on an airplane, you'll notice that. The airplane doesn't start turning and then bank, it banks and then it starts to turn. It naturally follows.
Just following up question, how does it bank then?
There are these little things on the outside of the wing called ailerons, and they put one up and they put one down, and that changes the flow over the wing, and then that you get less wind. Like if you get less lift on this wing and more lift on this wing, it'll naturally bank like that. Or if you switch, you get less lift here and more lift here, it's going to impart a torque on there.
Okay, thank you.
Yeah, well, I think we have to officially end, but we can stick around if you have any more questions about airplanes or. Thanks for coming out with our dry ice adventures. Who's ever closing?